It says a diagram below not drawn to scale. Any diagram that is not drawn to scale means it's not drawn to the exact size. So you cannot use none of those geometry instruments, measuring instruments, to find anything. If you try or you attempt to use them, you are not going to get the correct answer. So sometimes in paper twos, there may be one question, maybe it's not always there, but sometimes they may give you one question that actually says drawn to scale. If you see that, you know you can use any of those measurement instruments and you will find the lengths and angles and stuff. But when the question says not drawn to scale, you either have to use a rule or a couple of rules or formula to figure out whatever they want you to find for that question, right? So it shows a circle with center O. So O is the center of the circle. The points A, B, C, and M are on the circumference. Normally, when you're reading, this is what I recommend, right? You don't have to do it, but I think it helps, especially if you're not too good with circle theorem as yet, right? Because I know some of you are learning and some of you are revising at the same time. When you read, well, based on what I read just now, I already picked up two things with this diagram. I wonder if anybody's with me here. So let me ask. When they said that with center O, did anybody realize which of the rules that I went through earlier on that is in connection with center O? Because everything they're telling you is hinting to something that could help you solve the answers of the questions later on. Okay, I see somebody say angles are the center. Not really, but good at them. I see somebody say semicircle. You are definitely onto something there. That's correct. So again, people who not familiar, I don't expect you to remember angles at the center or angles in a semicircle if you heard it for the first time or the first time in a long while. But the more you hear it, the more you would remember it. So anytime, um, by the time I read actually angles, um, sorry, center. Oh, I looked at the circle. You all probably didn't realize I looked at the circle, but I did glimpse the circle. And I saw the diameter. And when I saw the diameter, I looked again and then I saw this. Are you all seeing what I'm seeing? So for the person who said angles in a semicircle, you're correct. So you're most likely going to have these angles in a semicircle to answer the questions. Remember, this is 90 degrees. Okay, so as you read a question, try to think about which rule they really hinted to me here, right? In that way, it may help you to know by the time you have to find the angles, you may have to use this to help you out. The next part, sorry about that. It says ABC, ABC and M are on the circumference. That is also hinting to another rule. Did anybody figure it out? It said that A, B, C, and M are on the circumference. That is actually a rule. Which one is it? Anybody? I'm trying to help you all think for yourselves, right? Because it's one thing for me to tell you all, but when you have to think, eventually you all would realize. Cyclic quadrilateral. So yes, it is a quadrilateral, but it's actually hinting the cyclic quadrilateral. And to show you all that it is a cyclic quadrilateral that they're not telling you cyclic, they want you to figure out the cyclic, they're telling you. If we draw a line connecting A to B, A to C, C to M, and close off the shape, you see a four-sided figure. And as I said earlier on, you have to make sure that all four sides, not sides, corners of vertices are touching the circumference. So A is touching the circumference, B is touching the circumference, M is touching the circumference, and also C. So they just hinted to you cyclic quadrilateral. Okay? So again, when you're reading these things, try to think about what rule is that about, or what is that hint about, because they're giving you a hint. Sometimes they would tell you certain things, but sometimes they don't tell you everything. They just give you hints, and then you have to figure out the rest. So we will most likely have to use cyclic quadrilateral in the question. What else are they saying? They're saying that the straight line where is CN? Um, from here to here. Okay, actually the whole line. Even though from C to M, but it's the whole line, is a tangent. So a tangent is any line drawn um outside the circle, touching the circle at one point. Now, that is also hinting to a rule. So let me see if anybody will be able to figure it out. There are a few rules, like three of them I think I went through before, a while back about tangent. It's one of them. Excuse me. Is anybody seeing it? Are you seeing what I see? I realize the people who answered are people who was in my classes before. Not all of them, but some of them. Okay, so let me see. Angles on a straight line. I mean, yeah, that too, but angles on a straight line, that is more geometry than circle geometry. I wanted a circle geometry, but you could also use angles on a straight line because so that's a good observation there. Um, if you know this angle, you could figure out this angle because angles on a straight line must add up to 180 degrees. So yeah, that's a good thing. I'll just put it on the side here. So there are others. I think you're not seeing it, but I am seeing alternate segment theorem. To see alternate segment theorem, you must see some triangles that are connected to the tangent. So that there is an example of alternate segment theorem. I don't want to say too much. I'll leave that just so. So, um, there's another version of it too, So I'm just going to do some sketches. The reason why I'm sketching these things, that's for people who not accustomed with circle theorem, as I told you, not that confident or it's new to you. But once you get really good with circle theorem, you wouldn't have to be doing no sketches. Well, it depends on how much you practice, though. So there's alternate segment theorem here, but there's another one that I'm seeing as well. I'm not sure if we will have to use that one, but just in case, I'm seeing another version of alternate segment theorem. This one over here. As long as you could get a triangle, all three corners must be touching the circle, right? All three vertices. So that is also another alternate segment theorem. So I know some people probably got it last week, but I hope you all took photos or screenshots of the rules I was doing before we didn't have it. Okay, so there's this other version of alternate segment theorem. Okay, it looks something like this. Okay, that's all they said. They said, and it's perpendicular to BN. Okay, so they already give us a 90 degrees with this perpendicular stuff they're talking about. So if we, oh my, yeah, this line, this tangent, and this other line here, it's perpendicular. That's why they give us some 90 degrees. So sometimes in maths, you want to break down the question, see what you can see how many rules you can identify in circle theorem, so that you can the question would become easier to some extent for you to answer it. Um, okay, so I need to figure out what are the angles they want us to find. I just scroll down to find them. So they want us to find angle A, B, C. I'll write them on the screen and then I'll head back up. So we need to find angle A, B, C. What else? For 2 marks. And it said given reason, eh? So normally you would get 1 mark for your angle, the size of the angle once it's correct, and 1 mark for your reason. Your reason is what rule or rules did you use to figure out the size of that angle. We also have to find CMB and NCM. Okay, so heading back up here, the first angle they want us to find is ABC. So I'm going to take off my sketch. Now, when they give you 3 letters to represent an angle, the angle is always located by the letter in the middle. Now, B is over here, but there are two angles at B, but they're not asking us for 2 angles, they ask us for 1 angle. So to be certain of which angle you need to find, you could start from A. Where is A? You could trace from A, head down to B, and then from B, head down to C. So the correct angle at B is this one, not this one. So that's how you could figure out which angle you really need to find, right? Okay, see some people sending me answers already. You may be correct, I'll confirm in a moment. Um, so we need to find an angle. That is shaping up like alternate segment theorem, but I don't think that's going to work. But it's also shaping up with angles in a semicircle. If I close in the shape, right, and it's looking like this, and it's looking like that, angles in a semicircle. So some of you would know or remember that this is 90 degrees. So once we know 2 angles in the triangle, it's easy to find the missing one, right? Okay, I see. Okay, on here. There's somebody delete something, I don't know. Right. So I'm just doing a sketch outside because I know somebody's just looking at these diagrams. Or I could have used this one, I know already where with me. So I can use this one right here. This is 58 degrees. This is 90 degrees. So if we say 58 and 90, we would get 8, 5 and 9 is 14. And all triangles have a total of, you all need to remember that 180 degrees. So we say 180 take away 148. We borrow from the 8, it becomes 7. So this will be 10 take away 8 is 2, 7 take away 4 is 3, 1 take away 1 is 0. So I saw some people saying 32 degrees. You all are absolutely correct. So if anybody have any questions, if anybody's lost, if anybody's unclear, feel free to let me know so that I could probably explain it a little bit more, something like that. So yeah, the people who didn't say anything, are you all good or not? Or getting there? Getting there? Okay. Getting there? Okay. I do appreciate you all's responses. All right. The next thing I was going to do. Okay, so moving on. Wait, I not finished yet. I forgot to write it here. So the answer is 32 degrees, and you have to give a reason for the next mark. So what did I use? Angles in a semicircle. angles in a semicircle. Okay, good for good practice. Anytime you find something in these diagrams, you can also put it here as well because it may come in handy because remember we still have two angles to find. So that could help you find the other angle. So everything you know or you find, put it in a diagram. Yeah, so everything you know or you find, put it in the diagram. Okay. Um, so I'm taking off this. I don't know if anybody's writing. If anybody's writing anything, let me know. I guess that's a no. So the next angle we need to find, oh no, let me put back the 90 degrees. The next angle that we need to find is angle CMB. Angle CMB. Okay, I see some people already find it. Good night, Egypt. Welcome back. So yeah, remember the angle is always located by the letter in the middle. So the angle that we wanted to find is the angle that's M. Okay, that is the angle that we need to find over here. Hmm. Okay, I see people sending me answers. That's nice to see. Right, so to find angle CMB, where is C? C is there, M is here, B is here. So you could do this to make sure that you are finding the correct angle at M because there are more than one angles at M. Okay, there are more than one angles at M. So the angle that we really need to find, the correct one is this one. Oh, I see why you all got that answer. So this one, shaping up with the cyclic quadrilateral. I know for some of you who are very new to this, it might take a while for you to pick up on it, but it's shaping up with a cyclic quadrilateral. And the angle that they want us to find is this same angle. I'm going over to the sketch, right? The same angle is this angle here, right? And this other one is 58 degrees. And based on the rule for cyclic quadrilateral, the opposite angles must add up to 180 degrees. So these two angles over here must add up to 180. So all you have to say is 180 degrees. Take away 58, and you will get the angle that you want at M. 8 was 0, can I take away 8? So we can borrow from this 8, it becomes 7. 10 take away 8 is 2. 7 take away 5 is 2. 1 take away nothing is 1. This angle here is 122. 122. That's the same angle over here. Right, so this is 122 degrees. And remember, you all need to put a rule for the question. So the rule, not rule, it's rule here, but they call it reason. So the rule or reason is going to be what I use. What did I use to figure out the angle? The information I know about cyclic quadrilateral. So for those who don't know, a cyclic quadrilateral is a four-sided figure, just like the one I have highlighted here. A four-sided figure that's in a circle and it's touching the circle at all its corners of vertices, right? So the answer is 122, and the reason for it being 122 is because of the cyclic quadrilateral. If anybody have any questions, let me know. For those who got it, see you all ready to put circle theorem to rest. Okay, let me see. Why take away and not add? Add. What am I adding for though? So remember, right? Opposite angles in a cyclic quadrilateral must add up to 180 degrees. So if it is, one of the two angles, to find the other angle that would add up to 180 with that given angle, you have to take away from 180 to figure it out. I hope that making sense. It's not like you're trying to say, okay, what is the total degrees with those two angles you'll add? I get 180. No. The reason why you need to know that these two angles here, which are these two angles here, when you add them, you must get 180. So you don't need to go back and add anything. As long as you know one of them, like how we knew the one that's 58 degrees, all you have to do is take 180 because both of them must give you 180. If you add them, take away the 58 and you get what the other one is. So I don't know if that answered your question. I hope it did. If it didn't, let me know. Okay, great. Right, so this last part of this question here, let me just write this properly. This is two, but not even looking like two. Oh man. Right. The last angle, we need to find this angle NCM. Remember when they give you three letters to represent an angle, the angle is always located at the letter in the middle. To be sure, where's angle C? Angle C. Angle C has a lot of angles. There's an angle over here. We already know that was 90 degrees. There's one here. There's one here. So which angle they want? So that's why, to be sure, certain of which angle you need to find. Let me just put back this. I just want to rewrite it a little bit more cleaner. To be certain of which angle they want you to find, you can trace from N. Where is N? Trace from N, head to C, and then go to M, and you will be able to figure out which angle at C. Um, N is where, right, M to C, back to M. So the angle at C that they want is this one over here. That angle right over there. Now that looking like, I didn't really draw that one, but we'll figure it out. We will figure it out. I see some people like they already got it. And it seems to be the people who have been here for a while. But anyways, what shape is this creating? A triangle, right? A triangle normally has three angles. Let me just draw a sketch out here, right? So you can see it by itself as well. We already know that this is 90 degrees. That symbol is 90 degrees, right? So this is 90. They want us to find this angle here. That's the one by C. So if we can figure out this angle here, then we could figure out that angle. But how are we going to figure it out? I'm gonna I'm going to show you how we could figure it out for those who not seeing what I am seeing or what some of the others are seeing. If I take off this line, right, I'll leave everything else, put back this so we know it's this angle I'm trying to find here, right? Somebody said it earlier on, they talked about a straight line. Angles on a straight line. There's an angle on this straight line over here. I'm going to draw it outside as a sketch, right? Because I know you have a host of lines. So sometimes that's why these questions could trick students because you see a host of lines and then you don't know how to look at the stuff too well. But you could do a little tracings outside, do a little construction, you know. So since we found that this angle here is 122. And it's a straight line. The angles on a straight line, right, must add up to 180 degrees. So since the total amount of degrees on a straight line is 180, To find this angle, we could say 180 degrees. Take away 122. And we get that missing piece there. Somebody send something here. Okay, people sending answers. I see you all in the chat. So you're gonna take away 2, but from the 8, 7 we remain with. So for the one here, 10 take away 2 is 8. 7 take away 2 is 5. 1 take away 1 is 0. So this angle inside there is 58 degrees. So since this angle is 58 degrees, right? That's not even writing properly. Let me just redo my sketch. It's a little bigger so I can fit some stuff in it. Um, yeah. So this angle is 90 degrees. This other one I just found it to be 58 degrees. So the thing about maths is this. If you know the sizes of two angles in a triangle, and you only have one angle to find, it's not that difficult, right? You add the two angles that you are given, or that you know, and then take it away from 180 because a triangle, the sum of all three angles in a triangle must be equal to 180 degrees, okay? So 90. Uh, yes, you have to know exactly what you're doing. Okay, yeah. So what do I have? Yes. So adding this, right? 0 add 8 is 8. 9 add 5 is 14. So this will be 148, right? And then the total amount of degrees in any triangle, it doesn't matter what type of triangle it is, as long as it's a triangle with three sides, all three angles must add up to 180. So since we know that two of the angles will give me a total of 148, we can take away that 2 figure out the size of the missing angle. Well, from here, we have 7. 10 take away 8 is 2, 7 take away 4 is 3, 1 take away 1, 0. This angle here is 32 degrees. That's the same. That almost kind of right, good boy. That's the same angle that C that they asked us for. So this angle here is 32 degrees. So we put the answer as 32, right? But remember, what did we use to figure that out? We used angles on a straight line. When I took 180 and take away 22, I got 58 over here. And then, focusing on the triangle, I added the two angles that I knew, taken away from 180. So all we could say in the shortest way possible for the reasons would be angles on a straight line, angles on a straight line, and I need to erase this because I don't really have much space to write anything else. So angles on a straight line and what's the other one? Angles on a triangle. Now it have students who would write this out in detail. That's your choice now. Some people will start to say things like the straight line NB or BN or however you want to call it is a straight line so that we take away 122. Some people are going to host that details. Now, to me, you don't have to do that. Let me tell you why. The reason why you don't have to be explaining a whole set of things because you only get 1 mark for your reason though. So why you explain a whole set of things when you already have working to show that? So don't make, well, to me, just wasting time doing that. Because look at this. The answer for AB, you're getting 1 mark for that 32 degrees. The next mark given your reason for your reason. Same thing for this one. Which one is that? When we found CMB, you get a 1 mark for this angle.